Hello students, I am your Akshay Sir, and today we will be learning one of the most important concept in mechanics, which is instantaneous center of rotation. So today we will be starting with the definition of instantaneous center of rotation, why exactly we use it, and in which particular set of problems we need to use it, and then using this particular concept we will be solving this particular question which I have mentioned in the screen right now. So as the name suggests, instantaneous center of rotation. The meaning is, at that particular instance, what is the center of rotation or what is the axis of rotation? So till now, whatever rotation we have studied, in that the axis used to be fixed. But in many situations or in many mechanisms, the axis is not always fixed. At different instances, we have different axes. So what we have to do to evaluate different properties, like say the angular velocity or the velocity, we need the position of the center of rotation or the axis of rotation at that particular instance. So today I'll be teaching you how to evaluate the location of the center axis or the instantaneous center of rotation, and then what is exactly the application of this particular concept and how to apply it in particular questions. So first of all, instantaneous center of rotation, there is a rule of evaluating the location. What we need to know is we need to know the direction of velocities of any two particular points or any 2 points which are located on that particular rigid body. So once we know the direction of these 2 points, the direction of velocity of these 2 points, what we have to do is we have to draw a vector or we have to draw a line which is perpendicular to the velocity vector. For example, in this particular question, as the question suggests, your rod BC is moving anti-clockwise. Okay, it's rotating anti-clockwise at an angular frequency, or like say angular velocity of 300 rpm. So that means velocity of point B or the velocity of B will be in this direction, that is perpendicular to your rod BC. That means here I have the direction of B. So I'm just indicating here in this way properly. So this thing is velocity of B. Okay, that means I know the direction of point B or the direction of velocity of point B. Also, like by applying some 3D visualization in your mind, we can easily evaluate the direction of velocity A. Direction of velocity of A is going to be in this direction. Perfect. That means for rod AB as well as for rod BC, I mean for BC anyways, we know the velocity, the center of rotation is going to be point C itself. But for your rod AB, we know the direction of velocity of B as well as the direction of velocity of A. We just need to know the direction. The magnitude we can evaluate later, but for evaluating or for locating your ICR or the instantaneous center of rotation, we need the only the direction of velocity, not the magnitude. Okay, so this is the direction of A or velocity of A. Okay, so whenever we need to evaluate the location of ICR, first of all, evaluate or write the direction of any 2 points on the rigid body, and then draw a line which is perpendicular to the velocity. For example, in this particular situation, I need to draw a line which is perpendicular to velocity of A. So here, can I draw it like this? I can easily draw it. So I'm making it dotted because this is not the exact part of the figure. So I just need to know, we all just need to know that I am just drawing this line for evaluating or for locating the ICR. Okay, again the velocity of B is like this. That means we have to draw a line perpendicular to it. The perpendicular to VB is nothing but along the line or along the rod BC. So I'll just simply extend this BC in downward direction because I know here in this particular location there is going to be the center of mass or ICR. Okay, so let me just draw or extend this BC. And all the ICR questions, this is a standard procedure. So wherever ICR is involved or wherever instantaneous center of rotation is involved, this is the particular procedure that you need to apply. So after extending the line which is perpendicular to the given velocity vectors, where the 2 lines intersect, that particular point becomes your instantaneous center of rotation. So this is how we evaluate or we locate the instantaneous center of rotation at that particular instance. So this I represents the instantaneous center of rotation for rod or for rod AB. at this particular instance. Okay, and first of all, why do we need instantaneous center of rotation? For now, I have just only told you how to evaluate ICR, but then let me read this particular question, and then I'll tell you how exactly we apply the concept of ICR to evaluate whatever thing they have asked in this particular question. Okay, the crank BC of slider crank mechanism is rotating at a constant speed of 300 RPM in anti-clockwise direction. Okay, that means this particular rod BC, okay, here we have a slider crank mechanism, and at this particular instance, your rod BC is rotating at a speed of 300 RPM or 300 rotations per minute. It's a practical unit. First of all, we'll need to convert it in your SI unit. Okay. Determine the velocity of piston A at this given instant. Okay, so at this particular instant, what is the velocity of this slider A that we need to evaluate? Okay, so looking at the question, we know that this question is question related to ICR. So I've already taught you how to evaluate the location of ICR. So that's a particular standard procedure, like select the rod or select the rigid body whose ICR we need to evaluate, and you need to know 2 points whose velocity you know, or the direction of the velocity you know. So we knew that direction of VB and direction of VA. So we drew a line which is perpendicular to the velocity vector, and where these lines intersect, that particular point becomes your ICR, or the instantaneous center of rotation. Okay. And once this ICR is located, I'll tell you how to exactly apply this in particular or in different questions. So first of all, we know omega of this rod BC. We know that rod BC is rotating with 300 RPM. So here I'll simply write it. Omega BC is simply 300 RPM. 300 RPM. RPM is a practical unit, but we'll try to keep everything in SI unit. Okay, so 300 RPM, how to convert it in radians per second? It is simple, 300 into 2 pi by 60. One rotation is 2 pi radians and 1 minute is 60 seconds. From that, we can easily convert RPM to radians per second. So this particular is radian per second. Okay, now if I evaluate this, your answer is going to be 10 pi. I hope I'm doing it right. Yeah, it is 10 pi radians per second. Okay. At this particular question, this length BC is 0.1 meters. And this length AB is 0.4 meters. Okay. Just keep that in mind. Now, omega BC is 10 pi radians per second. We can easily evaluate velocity of B. We know that velocity of B is going to be omega BC into the length BC. Okay, it is simply V is equal to omega R, that particular equation I'm applying. This into is a multiplication sign, don't get it confused with your cross product. Okay, omega BC is how much? It is 10 pi. I'm keeping everything in SI unit so that answer gets easier. And BC, the length of BC is 0.1 meters. So my answer will be in meters per second, and this particular answer is pi meters per second. Or simply I can write 3.14 meters per second. So evaluating the magnitude of velocity of B is pretty easy. As such, we are simply applying V is equal to omega R. But here the main question is we need to evaluate the magnitude of velocity of A. So we know that velocity of A is going to be omega of AB. Okay, the angular velocity of rod AB into distance of A from its particular ICR. Okay, now distance of this point A from this particular ICR is AI. So we need to keep in mind that first of all, we need to evaluate this value of AI. Also, we don't know this omega AB. Now, how to evaluate this omega AB? We know the velocity of one point on this rod AB. Which point? I'm talking about point B. So using rod BC, we evaluated the value of VB, and then using VB, we'll be evaluating the value of omega AB. Okay, so here I'll write the equation first. Omega AB. Omega AB is given by velocity of B, which we already know, divided by its distance from its particular ICR, or the instantaneous center of rotation. So distance of this point B from its particular ICR is this entire BI. and we don't know the value of BI. So this also we need to evaluate. So these are all geometrical questions that I'll tell you exactly how to evaluate for this particular question. But in general, for evaluating or for solving these ICR questions, your geometrical knowledge should be pretty strong. Okay. So this BI also I need to calculate. So I need to calculate AI, I need to calculate BI, and how exactly to calculate geometrically, that I'll be teaching you soon. Okay. So we need omega AB, we need A. So first of all, let us calculate the values of this AI and BI. So where is this AI? This is AI, and where is this BI? This is BI. To calculate BI, we need to calculate this length IC, because BC we already know. Now let's see the geometrical manipulation or the geometrical calculations what we do. So first of all, looking at the figure, this particular angle is 60 degree. That means this entire angle is going to be 120 degree. Simple supplementary angles. Okay. Now if we focus a triangle ACB, and triangle ACB, we know the length of these two sides. We know the length of side AB and we know the length of side BC. We also know the angle. Okay. And we need this length first of all, because if we evaluate this length of AC, let me write the length of ACB X. If we evaluate the length of AC, then using basic sine rule, we can evaluate these two parameters also. We can evaluate AI and then we can evaluate CI. Now, how to evaluate this C for or how to evaluate this X? We will be applying the concept of cosine rule. So if I consider triangle ACB, let me write here, in triangle ACB, what is going to be the value of cos of 120 degree? So according to the cosine rule, it is going to be cosine of 120 degree is going to be x square plus 0.1 square minus 0.4 square, the whole divided by 2 into x into 0.1. I hope you know what exactly is cosine rule is. So here I am applying cosine rule to evaluate the value of x first. So let me write the equation here. It is going to be 0.1 square plus x square minus 0.4 square, the whole divided by 2 into x into 0.1. Okay. X square plus 0.1 square minus 0.4 square, the whole divided by 2 into x into 0.1. Also, we know the value of cosine of 120 degree. Your cosine of 120 degree is minus half. Okay. How we can evaluate is cosine 120 I can write as cosine of 180 minus 60. And then cos of 180 minus theta is minus of cos theta. So minus of cos 60 degree is going to be minus 1 by 2. I hope you know the trigonometry behind it. So I'll be just solving this equation. Minus 1 by 2 is equal to, minus 1 by 2 is going to be, minus 1 by 2 is going to be this particular thing which we have written here. So minus 1 by 2 is equal to 0.1 square plus x square minus 0.4 square, the whole divided by 2x into 0.1. Now I have already evaluated, I've already solved this equation. So when we simplify this equation, you get a quadratic equation, and then evaluating the roots of quadratic equations is pretty easy. I hope you will do it on your own. I'll just simply write the solution what x I'm getting here. So the value of x that I'm getting in this particular situation is 0.34 meters. 0.34 meters. That means this particular length AC, this particular length AC is going to be 0.34 meters. Now I'll just write here 0.34. Now consider triangle AIC. If I consider triangle AIC, we know that angle A is 90 degree. Also, these are vertically opposite angles. So if this angle is 60 degree, this angle is also going to be 60 degree. So if this angle is 90 degree, this angle is 60 degree, this particular angle is going to be the angle sum property of triangle. Addition of all the angles of a triangle should be 180 degree. So 180 minus 60 minus 90, this particular angle is going to be 30 degree. So it's a nice 30, 60, 90 triangle. Okay. So in this triangle AIC, we know the value of AC, which we already evaluated, which is nothing but 0.34. We need the value of AI and we need the value of AC. So we know all the angles and we know what one particular side. So in these particular situations, what we do, we apply the sine rule. So first we applied the cosine rule in triangle ACB. Now I'll be applying the sine rule in triangle AIC. So how to apply this? A side divided by sine of angle opposite to that particular side. That ratio remains constant. So here I'll be writing in triangle AIC. So in triangle AIC, I will be writing AC upon sine of 30 degree. See this side length AC divided by sine of opposite angle. So sine 30 degree. So AI upon sine of 30 degree is equal to, okay, I'm sorry, this was AC. Really sorry. This was AC. So AC divided by sine of 30 degree. Then I have AI and the angle opposite to AI is 60 degree. So AI upon sine of 60 degree is equal to, we at the final side is CI and the angle opposite to it is 90 degree. So CI upon sine of 90 degree. CI upon sine of 90 degree. Okay, this particular ratio remains constant. This is simply a sine rule. Okay, we know the value of AC. AC which we already evaluated is 0.34. So here I'll be writing 0.34 the whole divided by what is sine 30 degree. I'll just simply write sine 30 degree first. Now using this particular equation, you can evaluate AI, also you can evaluate CI. So let me write it how to evaluate these. So AI is nothing but, your AI is nothing but 0.34 by sine of 30 degree into sine of 60 degree. Okay, so it is going to be 0.34 the whole divided by sine 30 degree is half and your sine 60 degree is root 3 by 2. Okay, your sine 30 degree is half, sine 60 degree is root 3 by 2. If I evaluate this 2 and 2 are getting cancelled out. So AI is nothing but root 3 times 0.34 and root 3 times 0.34 is 0.59. Don't worry, I've already done the calculations. So 0.59 meters. So I've already evaluated the length of AI, which is nothing but 0.59. So I'll just write here nicely 0.59 meters. Okay, then I need to evaluate this IC again from the same equation. I can easily evaluate CI is going to be sine 90 into this particular ratio, 0.34 by sine of 30 degree. Sine 90 is anyways 1, so don't need to worry about it. So 0.34 the whole divided by half into 1. So this thing is 2 times 0.34. So CI is simply 0.68 meters. So I'll just write as 0.68 meters very nicely, 0.68 meters. Okay, so now you have realized that the ICR particular concept is really easy, but the hard part is evaluating the geometry of the particular question. Okay, so once I know the value of AI, I will simply substitute the value of AI and BI. Okay, IB is going to be, I'll just simply write IB. IB is simply BC plus CI. BC plus CI. The value of BC is already given, which is nothing but 0.1 meters plus value of CI, which we already evaluated, which is 0.68. Okay. So here your answer is going to be 0.1 plus 0.6, which is nothing but 0.78 meters. This is your value of IB. Okay. And once you know IB, I'll be evaluating omega AB first. So omega AB is going to be, I'm just writing this particular thing here. VB is how much? VB which we evaluated is 3.14 meters per second. So 3.14 the whole divided by IB, which is nothing but 0.78. So all we have to do is evaluate this 3.14 the whole divided by 0.78. I'm using my calculator here. So the answer is 4.02 approximately. So I'll just approximate it. I will write 4 radians per second. 4 radians per second. This is the value of omega AB, or the angular velocity of rod AB. And once we have evaluated the angular velocity of rod AB, I can simply evaluate velocity of B using this particular equation which I have written. So here I will be writing velocity of A is going to be omega AB into its distance from that particular or its particular ICR. So it is AI. So here I'll be writing AI. So omega AB, which we already evaluated, which is approximately 4 radians per second, multiplied by AI. So the value of AI that we evaluated is 0.59. So here I'll be writing 0.59. Okay. Now what is 4 into 0.59? 4 into 0.59 is approximately, I'll say 2.36. 2.36 meters per second, which is velocity of A. This is a final answer. So a big question to evaluate this particular parameter, we needed to do all this hustle that we did. Okay. So from this, you must have realized this one thing, that the particular concept of ICR is easy, and how to apply that theorem or the concept of ICR. All we have to do is, when we know the velocity of one particular point, using that we evaluate the angular velocity of that particular rigid body, and using the angular velocity of that rigid body, we evaluate whichever velocity we need to calculate. Okay, so the procedure is first locate the instantaneous center of rotation. Okay, and then whatever I told you, from a velocity, evaluate angular velocity, from angular velocity, evaluate velocity of other particular point. Okay, now applying this concept of ICR is easy, but the only harder part here is the geometry behind, the geometry which goes behind it. Okay, so that you need to practice. I hope you have understood the concept of ICR and understood how to solve this particular question. If you need any other concept of engineering mechanics, let me know. I will cover that concept as well. Till then, bye bye, see ya, take care.